Question 13. Which pair of compounds does not form a racemic mixture when the compounds react? So a racemic mixture at equal amounts, equal concentrations of both enantiomers. So if we've got equal concentrations or equal amounts of both enantiomer, then we need a chiral carbon in there. That's a carbon that's got 4 different groups attached to form 2 different kinds of enantiomer. So the question is saying which one hasn't got chiral carbons when it's reacted. So we're looking for something maybe symmetrical, so automatically I'm drawn towards D because I've got 2 methyl groups. So D looks as if it's automatically going to be the answer, although I can talk you through why the others are not. So A, if HCl joins across the double bond by electrophilic addition, then what you've got is you've got a chiral carbon on carbon number 3, I assume, where let's say the Cl goes, so if the H goes on carbon number 2 and the Cl goes on carbon number 3, although it wouldn't matter if it were the other way around, this carbon would have a CH, it's already got one H, it'd have a CH, a CH3, a Cl, and then a CH2, CH3. The Cn bonds on with nucleophilic addition. The Cn bonds on with the lone pair of electrons on the C would attack that C plus there, and the delta minus there, the electrons would go onto the oxygen, then it would react with some dilute acid or some methanol to produce H plus. H plus would join on and make an OH, so I'm going to get Cn here, OH, H is already joined, and I've got a CH2, CH3, so this carbon would be a chiral carbon here. HCl across the bond, well, the major product would form a CH3 here, where the H joins onto the 2 H's, the carbon with the 2 H's already here, and the Cl. This would form a chiral carbon on carbon number 2 because it would have a CH3, a CH, a CCl, and a CH2, CH3, whereas this Cn would bond on here and form CCN, 2 methyl groups, so automatically this C hasn't got a chiral carbon, and the OH would form from the O. So the answer is D because of these 2 methyl groups here. This carbon's not going to be a chiral carbon. Question number 14, let's have a look what's happening here. We've got ethane forming chloroethane via a free radical reaction involving ultraviolet light and chlorine. Then we've got nucleophilic substitution as the OH bonds to the C of the CH2, that polar bond, and releases Cl minus and substitutes. This is at the OH minus is a nucleophile, an electron pair donor, so we'd replace the Cl here with nucleophilic substitution. We've got a dehydration reaction here where the concentrated sulfuric acid is removing water. It's removing one of these H's from CH3 to make CH2, and on the adjacent carbon removing the OH. So dehydration reaction, and then we've got Br2 adding with electrophilic addition across the double bond. So which one's nucleophilic substitution? This one here is nucleophilic substitution. Incidentally, it'll be in cold water, otherwise it would be elimination and it would form ethene, but we've got nucleophilic substitution of the Cl.